Welcome to CIS 137, Class 10. Hope you all had a good 4th of July yesterday. Let's get started. Someone just learning to master visual design could learn a lot by ignoring everything else and focusing on mastering just white space. This is David Kadavi. He wrote a book called Design for Hackers. I'll show you. And it's an online course too. Recommend checking it out. It's pretty interesting. It talks all about how white space works and how you can use any of your themes for your websites. And if you look here, the site looks pretty plain, but it looks really professional because it's using a lot of elements of white space here to separate content. Recommend looking into that if you're interested in design or just making your pages look professional. All right, so today we're going to go over passing values among components, spacing and sizing using CSS, and composition of components. So 2 Reacts and a CSS. So we'll jump right in. So if we're passing values in React, there are 2 directions you can go. Parents can pass values to a child, or a child can pass values to parents. And that's all you need. So children don't need to talk to children, just that bilateral communication between the children and their ancestors. So how does that look? How do parents actually pass values to children? So the parent-child communication happens through the attributes on the JSX, and those end up as props in the child component. So when we pass inside the parent component, if we have a child component and we set the value attribute to hello, and then we when we render, the child component will have a prop inside props called value that it can use, and it will have the value of hello in this case. Now, how do children talk to parents? So child to parent communication is a little less straightforward. So in order for the child to send the value back to the parents, it has to be done via a callback. Now, callback functions, as we learned a couple classes ago, they are functions that are called when an event happens. So in this case, the parent could have a method inside of it called handle change. The parent passes this method, handle change, to the onChange attribute on the child component. So just like the initial prop, the value we looked at here, the callback function will be passed to the props.onChange value. So this is step 1. So this is setting up that link, wiring the communication. Then to actually use the communication, start down here. The child calls the callback function when appropriate. So when the value changes, the child component will have something like this .props.onChange, and it'll pass a value, and a changed value perhaps. Since that was a call onto the parent's function, it gets passed back to the parent, and the parent can handle the change. So the parent's handle change definition would look something like this. It would have an argument for the new value or parameter, and it would do something with the new value. Those are the two ways to communicate in React. So there's the first way, the parent passing down through props. The second way involves setting up the callback and then making the callback from the child to the parent. So let's do a demo. Where are you, Chrome? Start a demo from scratch for you. Show you how to use CodePen too over here. So I've showed this before. I'm going to show it again. To use React with CodePen, we go to JavaScript. We choose Babel as a transpiler to convert our JavaScript to, or convert our JSX into regular JavaScript for websites to actually be able to use them. We add React DOM, and I think that's everything. And we can give it a title, call it passing values. Okay. In React, we need a root element, or we need some kind of element we can inject into. And then we can render into that component. Is right without looking. I think I'm pretty close here. Let's see what's wrong. So we have the React DOM.render. We don't have the hello showing up down here. So when you have something like this, I think it's this right here. There we go. So when we're writing in WebStorm, you don't need the React.component because you usually import component in the import statement. All right, so we have this app just renders hi. Show the parent and create a parent. And this is going to render a child. You're going to set this as username. To access a prop, we're just doing this.props and the name of the attribute that was passed in. And then we're going to render that parent component. So we have hello Bob. So the parent is passing a value down to the child. Now let's say there is something else in the child that can make a callback to the parent. We're going to have a button and set its on click to the parent's callback function. So we haven't written the parent's callback function yet, but we're going to go ahead and call it. So the value, I don't think is going to work here actually. I don't think button has a value, but we can do this. Since the parent said hi to child, we're going to say hi back from the child. And here, we're getting the parentheses around that. So I didn't put parentheses around this one because it has, it's just one line. So now when we click say hi back, nothing yet. And here we could create our parents with a callback function. And we're going to pass that callback function down to the child. So we'll just create something called handle child click. And in this case, it's not going to take any values or user input. It's just going to take, it's just going to fire this click. So there's a communication by callback, but it's not actually passing a value back. So here we could do a couple things. Let's see. We're just going to print something to the console for now and show you how to debug with that. And we're going to add the onClick function here and set that to this dot handle child click. Now remember, if you want to use callback functions like this, using this, you have to bind this handle child click back to this parent class. In order to do that, we need to use a constructor. There are a couple ways to do this, but this is the most straightforward way. So we're gonna pass the props here, and then we're gonna do super props, and then this dot handle child click equals this handle child click dot bind this. So we click say hi back. Here it looks like nothing's happening. If we go to the console, we can see every time we click it, it shows child clicked. So if we want to actually pass a value, maybe the child could keep track of how many times it's clicked. So we could count in here. Then we could show a message. So I'm going to use backticks in order to use format string here. Child clicked count times. Now when we click it, we just see object times is passing back the button. So we need to pass back the oh, looks like I lost my screen sharing. Hold on. Okay. Start state equals click count. Zero. So it's not so straightforward to just call this dot props on click whenever the button's clicked. Now we need to call a function inside of child that will call this dot props dot on click. So we could have a handle click inside of the child as well. In this one, all we're going to do is set the state. Since we're depending on the previous value, we are going to use prev state. We're going to use the callback to set the state. I think this is almost right. Here we go. Okay, I think that works. So now we set the state to the click count plus 1, but we also need to make that callback. So ideally, we'd be able to, or we pull in this state after it's changed. But we can do it here as well. So we have this .set state, prev state, return click count, prev state dot click count plus 1, and we're going to go ahead and pass this dot props on click. We're going to pass it our state value at this time. So let's see if it worked. So we had these previous values. We're going to go ahead and clear them. We're going to say hi back. Still saying the old value. Where did I mess up? Oh, I never changed it right here. Okay. It's still saying the old value because I never hooked up the on click to this handle click. So we gotta bind the handle click method we've written here to this child function or child instance. So we're going to set handle click to this dot handle click bind this. And down here we can just use this dot handle click. Okay, go ahead and clear this. Now see, it's technically one behind on all of these. See, this dot set state, pre state, return click count, pre state, dot click count plus 1. All of this inside of here is happening asynchronously. So when you use callbacks, the callback generally happens sometime later. So when we set the state here, that doesn't immediately get applied to this dot state since we did it in this callback function. So this method executes, or this line executes, and it basically queues up a callback for later to calculate the new state. Then this line executes, and the current click count is passed, which you see from the beginning was 0, even though we added 1 in the beginning. To get around this, you could, do like this. For now, there's another way to do it, which we can talk about later. But this way, you get you're passing the change ahead of time, and the bad thing about this way is that you have repeated yourself. So there's 2 ways that the click count is increasing. But now you can see how many times the child was clicked. So we're passing data back to the parent, how many times the child was clicked through a callback. So this is a common pattern. This is a common pattern you'll see is the parent will pass a callback, the child will make the callback when appropriate. And that's how you pass values between components. Let's say you have 2 child components that you want to share values together with them. So in that case, you would never really have a direct child-to-child communication. You just communicate through a common ancestor, usually the parent. So the parent would communicate with child 1 through props. Child 1 may have values that child 2 needs, but child 1 would just pass back the value to the parent, and then the parent would communicate those values back with props to the other child. And then the other child could communicate through a callback with the parent, and that value could be passed on to the first child again. So you can see there's no link between the children directly. And this keeps things more modular, having just these 2 ways to communicate. So now, child 1 does not depend on child 2 existing. Child 2 could be replaced with child 3, and child 1 doesn't care. It does not affect the implementation of child 1. So that's what I mean by modular. So inside the official React docs, Facebook takes us to the level of talking about lifting state up. And this is a technique. I'm going to pull state out of the child component into the parent component, and that way the parent component controls the state and will update all of the child components appropriately. So in this case, I have a temperature app. Let me check out. In this case, you just have to put a temperature in Celsius in here, and it'll tell you if the water is going to boil or not. 150, nothing. 500, yes. And they make it fancy by allowing Fahrenheit temperature as well. So initially, the calculator just handles Celsius temperature. Then we want to add Fahrenheit. You can look through this example where the calculator will control the state of the temperature. Let me find it down here. I'm going to jump all the way down to the end. So the calculator has the state of the temperature, but whenever the two child components, so they have two child components, one for temperature input for Celsius, second temperature input for Fahrenheit, and they use callbacks. This dot handle Fahrenheit change, this dot handle Celsius change to communicate back to the parent, which is the calculator. So the calculator, when it handles Celsius change and handles Fahrenheit change, it sets the state. And then when you're setting state, that triggers, when the state changes, it triggers a re-render of the component. So inside the render method, these new values are used. So when the scale, which is passed from the temperature input, is F or Fahrenheit, then it converts the temperature to Celsius. Otherwise, it just uses the temperature because it would be Celsius at that point. Remember, if F is, or scale equals F is true, then it'll do this. If scale equals F is false, then it'll do this temperature. Fahrenheit, exact same thing, but an opposite. If the scale is C or Celsius, then it converts it to Fahrenheit. Otherwise, it just does the temperature. And then it passes those values back to the child components. Now, if we look at the child components, right here, child temperature input, it doesn't have any state at all. The only thing it does is it operates through props. So the stateless component, it just has the it just sets the temperature from the props and the scale from the props, and then it returns a input for that particular temperature. So whenever the temperature changes, so the hooking into the inputs on change, it calls handle change, and inside of handle change, it calls this dot props on temperature change e.target value. So e.target value refers to E refers to the input text box. Well, E refers to the event that was fired from the input text box. Target is the actual input text box, and then the value of that input text box is whatever the user entered in. So look at this example, understand it. We'll talk a little bit more about it later as well. These 20s are turning into 30s. It's okay. All right. I should say next up. Okay, any questions? Now, if you have any questions, if you're watching this later, obviously, just hit me up on Slack. All right, so let's jump right into spacing and sizing in CSS. So when you're laying out elements on in HTML, you need to be concerned about three things. You need to be concerned about the box model for that element, the positioning, and if that element is block or inline element. So what we mean by box model, so every single element in HTML is a rectangle or box. And the size of that rectangle is based on the margin, padding, the border, and the content of that item or element. Let's look at a diagram of that. So we see here are the layers of the box model. So you have your content in the middle. You can put padding around that content. And then a border around that content plus padding. And then after that, you can use a margin to push elements away from that content. So the padding and the margin are both transparent; they're clear. But the border you can make it invisible, but traditionally you give it a color, and then the content is whatever content you put into the element. So if you look at this CSS, it defines the background color of light gray for this div. It sets a width to 300. It sets a border to a 25 pixel solid green border. There's a 25 pixel padding you see here, and then there's a 25 pixel margin that's invisible as well. You can see it pushing away from the left edge of the screen. Now you can view this box model in Chrome as well. If you do the inspect, pop it up over here. This is what this box model over here is. So this is showing that the content is 300 by 198. So we can see that's because we set the width to 300, and the height is based on how much content there actually is in there, how much text there's in there. Then we have the padding, which is 25 pixels. And we can see it highlighting up on the here. We're hovering over it. Then the border is 25 pixels as well, and the margin is 25 pixels. So every element, even if it looks like a circle, if it's a circle image or something, it's still going to render as a rectangle inside of HTML. So let's talk about these properties we can use to define the box model inside of CSS. The first ones we're going to talk about are height and width. So when we're specifying the height and width of an element, what we're doing is we're specifying that inner content box. So this is where it gets a little tricky until I tell you a little trick later. But for now, when you're setting just the content size, then this padding and margin are going to be padding, border, and margin are going to be extra. So I have a good example over here. Let's go over here. Let's do one of these. This one has a width of 50% and a height of 200 pixels. Let's change this example. So we're going to set div1 class equals div1. We're going to make a div2 as well. Div2 is going to have a width of 300 pixels. Div2 is going to have the same height and the same width. Make it a different color. Right now they have the same height and width. Then we're going to add some margin to the red. See, it has a left margin, a top margin now. So jut it out. So we can change that to just do the top if we did margin top. They still are the same width and the same height. If we add padding, we add 50 pixels of padding. Now the div 2 is huge compared to div 1. So that padding was added in addition to the specified height and width. That can be a little confusing. You want your element padded, but you want that height and width to be, what the element actually is. But using this box model, that padding gets just tacked on to that height and width. This height and width only specifies that inner content area. We're going to look a way around this later, so I'm just going to leave this open. Okay, so next let's look at padding. So I'll show you a little intro to padding right here. So when you use padding, the padding property in CSS, you can specify a measurement to pad that element with, and that will pad the content area so that the content is farther away from the border, basically. So you don't have to pad everything equally. So this element has a padding of 70 pixels, so it has 70 pixels on top, 70 pixels on the bottom, 70 pixels on the left, and 70 on the right. But you can specify each one at a time. You need padding top, right, bottom, or left. So they can also use percentages or any of the dimension measurements. So pix, point, centimeter. I could use EMs, REMs, VHs, whatever you want there. So if we look at this, you can see it has 4 different paddings. And padding, of course, has a shorthand property too. So most of the elements in CSS will have a shorthand property where you can specify multiple values at the same time, and it condenses your CSS down. Excuse me, I'm sneezing a lot today. Okay. So whenever you see these 4 values, so in padding and margin, these work the same. They'll be top, right, bottom, left. I think it's even trickier because if you have only 2 values, or sorry, if you only have 3 values, then the first value is the top, the second value is the right and left, and the third value is the bottom. If you only have 2 values, then the first value is the top and bottom, and the second value is the right and left. And if there's only 1 value, then all 4 are the same. Padding again affects that space in the box model. It's around the content. Padding is always transparent. Next, margin is very similar to padding. There's an important distinction. So margin takes effect outside of the border. So we see a little green border here. If we have a margin of 70 pixels, then it'll basically push this element away from all the surrounding elements by 70 pixels. So in CSS, you can do the top right, bottom left, just like padding. So it's very similar to padding. You can set the pad or margin to auto though, where the browser calculates the margin. This is used when you want to center the element. Specify all 4 sides separately, or you can use the margin shorthand property. and this operates exactly like padding, where it's top, right, bottom, left. You can think of it like a compass rose. So north, east, south, west. Never eat shredded wheat. Top, right, bottom, left. So it's going in clockwise order. So here, if you set the margin to auto, it'll horizontally center the element within its container. So check this out. This is an important distinction as well. So when two elements are next to each other, one has a margin of something like 10 pixels, and the other one has a margin of 10 pixels as well, then the margin between those two elements is not 20 pixels. It does not add up. It does not stack up. Margins kind of overlap with each other so that the margin would only be 10 pixels. So if we look at this here, we have a top, right, bottom, an H1 with a 50 pixel bottom margin. And then we have an H2 with a 20 pixel top margin. Now, instead of being 70 pixels total, the margin between those is 50 pixels. We could use a more dramatic, or we could change these values so you can see it's not going to change on the right. That's an important thing about margins. So paddings are additive. They do affect, if you had a padding here of 10 pixels, we can just do padding top, be more clear. And then padding bottom, 10 pixels. Yeah, those are additive. If we remove this one down to 0 again, then you see it subtracted 10 pixels. That's one important distinction between margin and padding. The other is that margin's on the outside of the border and padding's on the inside of the border. So margin, border, padding, content. Last, we'll look at the border. So border, you can specify a style. You can see all these here on this page. You can specify the width of the border. So that's how many pixels thick it'll be. And then you can specify a color as well. Now, with any of these, you can change how the top, right, bottom, or left are styled individually. And there's a shorthand property just like padding and margin. So in this case, instead of being top, right, bottom, left, it's specifying the width, style, and the color. And you can use a border radius to curve the border. So the border sits between the padding and the margin. So in CSS3, like we talked about earlier, when you set the height and width of an element, it's setting the content area. But if you use this CSS3 property of box sizing, border box, your height and width is not just setting the content area, it's setting the height and width for everything up to the border, up to and including the border. So let me show you why this is more intuitive than the default setting size, the default of you setting the size of the content. We'll go to this in a second, but let's see that property in action first. So here we had our two divs that have the same height and width, but ultimately end up looking like different sizes. If we added box sizing border box to our red element, then the height and width affects uh, the height and width of the element after the padding is applied. So now this blue and red element are the same again. Now we're going to look at a way in a minute to set this in as a default value for all elements on your page. Fine, you can do that if this looks more intuitive to you. So here they show that example explicitly. So since this div, it has a width of 300 and a height of 100, and this one does too, but this one has a padding around it, this one ends up looking bigger. So div 2 has a 50 pixel padding, so it ends up getting 100 pixels extra in either direction. The box sizing, they're now the same. That padding is still applied, but that extra padding on the bottom was just cut off. So box sizing, border box. And then if you want to apply it to all elements, so applying this to all elements is safe and wise. So we can use this CSS, in our index.css. We can put it right here, or just look like that. And what this is saying with this wildcard, saying every element should get box sizing, border box. So we run it, we see they're still the same. Could add a different padding here. Could add some text in here. You see that red and blue are the same, but blue only has 10 pixel padding and the red has 50 pixel padding. Now that's a lot better than the old days of having to subtract the padding and the border from the height and the width to get them to match. So if you want the height and width to make sense, use this CSS up here. Set the box sizing to border box. We're talking about the box model, but how do elements actually get rendered to the page? So HTML elements are positioned according to the normal flow of the page. What does that mean? So the elements are positioned left to right and top to bottom within their container. So whatever element they are contained within, they'll interact with those other child elements. And we call this static positioning. And static positioning is the default way that elements are positioned on a page. There are other ways that elements can be positioned as well. If we look at CSS positioning. So you can have static, relative, fixed, or absolute. Fixed and absolute take the element out of the normal flow of the page. So for example, look at this bottom right here. This element is fixed to the bottom of the browser window. So when we scroll, we see it stuck to the bottom there. And an absolute allows you to position an element relative to the nearest position ancestor. So we're not going to talk about absolute right now, but just know it exists. The key takeaway is that position static is the default way that elements are positioned. And when that happens, if we look at this HTML here, I guess we can look at this one. So this P element, or this H2 element, is rendered first because it is first in the HTML. So that's right here, the position static. Then this P element is rendered after that, and that's right here. Then our div is rendered after that. So So this is just doing top to bottom. Each one is rendered in the order that it appears inside of the HTML. That's the normal flow of the page. And each element here is rendered as a box. So if we inspect this, we can dig in directly to that. As we hover over each of these elements inside of here, so we have our div down here. You see that's a rectangle. Our P is a rectangle. It has some padding around it. On top and bottom. Sorry, it has a 16 pixel margin around it on the top and bottom. And then we have an H2, which has a 19.92 pixel margin around it. So the margins are, establishing the rectangles. The rectangles don't really overlap, except for the margins can overlap, if you remember what we just learned. And this is the normal flow of the web page. Now, on all of these elements here, these are all block elements. What does block element mean? So in CSS, there's a display property that could be block inline or inline block. So let's talk about block elements first. Let's ignore that slide for a second. So when we have block elements, the element takes up an entire, it cannot have any left and right neighbors. So before the element's rendered and after the element's rendered, there is a break between the other elements. So there's a line break. If it's the first one, there's not really a line break there, but this div cannot have an element to the left or the right because it is a block element. It spans the full width. You could, you can specify the width of the element, but still, there could not be an element to the right. If we added another element down here, make it a span. Going to show up on the next line. So those are block elements. So block elements have a line break before and after, and they default to 100% width. So they take up the left or right width. Inline elements can have elements to the left and right of them. But the inline elements, you can't set a height and width. Or sorry, you cannot set a height. I think you can set a width. That in a second. I'm going to just fix that. And the vertical padding margin does not affect the surrounding elements. So these are just meant to be, embedded inside of text, really. So inline elements look more like span is an inline element. And then if we did something like strong on here, that's an inline element that makes text bold. So you can see this inline element does not have a line break before and after it. It just is within the actual text. It lines up directly with the text you have here. So let's look at the official W3 Schools definition for this. So the display property that we're using for inline and block inline block can also be used to hide elements on the page. So you could have things happen where if you click on something, it will change display from none to block. We're not worried about visibility right now. So by default, all of these elements are block elements. And there are more, but these are examples of them. Most elements you're going to see are block elements. So div, our default container, h1 and h6 are headers, the p tag for paragraphs, form, header, footer, section. These are all block level elements. They have line breaks before and after. They are 100% width, stretches out to the left and right as far as it can inside of its parent. And then inline elements, for example, span the anchor element. So when you do links, or the image element, just embed itself. It does not start on a new line and only takes up as much width as necessary. So with all of these elements, the image does not have to be just an inline element. You could force it to be a block element by setting the display property. Just look at these anchors. So we have these anchors just listed out one after another. If we just use the default display inline, and we can delete this, these links just show up right next to each other. We can force them to have the block display. And then I wanted to show you one last thing here. There it is. So inline block has some extra properties that inline does not have. So since inline, you could not set the height and width, or sorry, you could not set the height, you could not set the vertical padding or margin to affect other elements. You can use inline block to actually do that. I wonder if I have the link to inline block here. No, I don't. So with this, you can have let's check it out. So here they're using float as well. We can, okay, this is the old way. So this is the old way using float to do inline blocks. So to the old way, you talk about, but basically you just have a block and then you would set this float to make it be able to appear on the same line as other elements. So inline block, in this way we have each block is an inline block, so it can have elements to the left and right of it, and you can set the height and width. So it's kind of like the best of both worlds. But for the most part, for now, all you need to know is that the different ways that block and inline would render, and how you could use your div elements. Div elements cannot be left and right of each other. They can only be stacked on top of each other unless you change the display property of that div to be either inline or inline block. Any questions? So next class I'll try to time these better so they're actually 20 minutes. 30 minutes again. All right. So next we'll talk about composition of components. And this is another React centric lesson. So using composition is a software design pattern. This is really the bread and butter of React, that everything is a component and you just compose these components together. So it promotes modularity and reuse and a separation of concerns between the components. So also each component could have fewer responsibilities. So it's just concerned about the property it needs to be concerned with, and it technically reduces duplicate code and makes it easier to read those components and then maintain them, and replace them if you need to, or even modify them without worrying that it's going to well, modifying it in one place and infecting it everywhere is good, so you can fix a bug and it'll fix it everywhere. And having it in small components means you can just take that component out and replace it with another component, and the surface area of that component, the props and the callbacks it does, so you can just replicate those in your new child component, and the guts of the component can be completely different, but as long as it has that same way of interfacing with it through the callbacks and the props, then it's easy to just drop it in. And it's easier to test. I haven't talked much about testing yet. We may later. So there are some drawbacks to using the composition of components, and one is that you're going to have some boilerplate code. So that's just some code you'll have to write throughout everywhere that it just becomes rote. It's just happening all the time, and that's basically that setting up those callbacks, setting up those props, setting up that communication is can be a little tedious, I guess. And there's a lot of places where it could go wrong, like if you forget to bind the callback, then you'll have issues when you try to make that callback later. So you have to remember to write all that boilerplate code. And too many components could be overwhelming. So you could have a project that has a bunch of JavaScript files that are all different components, and you have to dig through all the components to find the component you're looking for. Really, for React, there's a React Developer plugin or extension you can put in Chrome that will help you navigate through those components. Otherwise, and you can use WebStorm, you can use the command click or control click to navigate through the components to jump right into the files that are necessary for that component. It can still be a little tedious jumping around from file to file. Third is that you must learn to think in React. So to use these components effectively, you have to know and you have to think about how these components communicate with each other, how they work together, how you can compose them all together. It's not a straightforward way of thinking, and we'll dig more into that as we go. And hopefully by the end of this course, or hopefully by the middle of this course, or I guess we're at the actual middle right now. So hopefully in the next couple of weeks, you'll have an understanding of how to think in React. Okay, so how can we compose elements or components together? So one way is called containment. So you can nest elements or components inside of a component, and the parent component can render children with props.children. That's one way. So this is kind of like a dynamic containment situation. So let's look at this example. So in this case, we have a fancy border component. And what this does is adds a fancy border around whatever is passed into it. So we use props.children to indicate this is whatever elements are nested inside a fancy border. So in our welcome dialog, we use our fancy border and we wrap the content we want to put a fancy border around. Now we can reuse that fancy border later. I don't know what good way to say this. By dialog, conclude dialog, something like that. Where we can create a new fancy border around a goodbye message. And fancy border takes a prop of a color, so we can give it a color of red. here we only have the welcome dialog. We're going to go ahead and smush these all together. We're going to put the bye dialog right after the welcome dialog. So we have the welcome, and then we have the fancy border. The red didn't get applied because if we go to our CSS, all we have defined is fancy border blue. So we go back to JavaScript, land first, go to our fancy border. We see the fancy border sets a class name of fancy border, and then fancy border, and then whatever color we passed in to fancy border red. So if we want to be able to affect the color, we're going to have to write fancy border red CSS. We weren't using CSS only. If we weren't using the external style sheet, then we could set the style directly as an inline style. But for now, inline styles are different from CSS. They have, you know, instead of having border dash color, you'd have to do things like border color. Now, because there's differences for this class, I recommend, or we're only using the CSS style sheet so that we can refer to W3 School's exact naming for these properties. If you're in production code, you may see some inline styles in React, depending on the maturity of the project or how it's organized. There's actually a push in React to have only inline styles. And there's benefits to that, in that you can use JavaScript inside of your styling, and you can still centralize and everything. Really, it's just being able to use JavaScript while you're running these styles, and being able to maintain your styles in code instead of a separate CSS sheet are what is drawing people into using inline styles. But for our class, always use these external styles. As a little tangent. That's one way of composing, and let's look at the way of composing in here. When we have two child components inside of one parent component, right here, so we contain two elements inside of our, this JS here. So we compose two elements together. So it'd be like a parent having multiple children. A parent component having multiple child components. Another thing you can do with composition is using specialization. So some components are a specialized version of a more generic component. Now, in traditional object-oriented programming, if you don't know this, that's okay. You would use inheritance to have a more generic object that you could then specialize into a more specific object. Now, in React, you should use composition instead of inheritance. And composition is when you have a specialized component that actually just returns the more generic component, but with properties set up so that it's specialized for this specific purpose. That's a little abstract, so let's push that down with an example. Once my computer starts responding again. So the example we're about to look at is a dialog box. So just like the one we looked at with the welcome with the fancy border, this dialog box, we have a generic dialog box that can take a bunch of properties and stylings in, and it'll render the page in a certain way. But then we want a more specific one. We want a reading dialog box, I think is what we're going to, where, here we go. Okay, my computer's back. We share it again. Yeah, sorry, my computer, I don't know what I installed, but there's some kind of bloat on it that's causing it to crash a couple minutes every now and then. Okay, so we're back. So let's look at this example. There's another one from the Facebook docs. So in this case, we have a dialogue that shows a title, it shows a message, and then it renders whatever children are inside of it, and uses a fancy border as well. So the sign up dialog is a specialized version of dialog. It has a way to sign up for a newsletter or something like that. So inside of the specialized dialog box, the sign up dialog, we are just setting the title. We're returning a dialog component, but we're setting the title, we're setting the message, we're setting the and then we're setting the children as well. So these children are getting passed as props.children, and they're being rendered as props.children up here. So we're not actually saying children equals this stuff inside of here. This is just how React handles the children. So the children get automatically assigned to the props.children. So inside of here, all this is handled by this component. So the handle change, the handle sign up is handle change and handle sign up are handled by this particular component. So if we put in a name here, we'll get this alert, welcome aboard. So doing it this way using specialization in this fashion allows us to basically make our generic component more powerful the more we add to it. So that later on, if we want to specialize in a different way, if we want to add a new event or whatever we need to do, get all that power that we had when we were decorating our dialog box for the sign up dialog specialization. So that means we could have another dialog box there with a different title, a different message, and then we can have and whatever pattern we pass into it as well. Because all of our dialog boxes would look the same, they would act the same, and we could add additional functionality to it. Say we want to add like a ability to close this dialog box. Well, we put X up here, and on click, that X would set the display to none for this whole dialog box. We're not going to implement it right now because I don't want to go over 20 minutes again, so I have a little bit more time. I recommend, if you want to try it out, you could, add an X to this dialog box that when you click it, it'll make the dialog disappear completely. So those two are kind of, two examples of how you can, contain two components together. And then the second is how you would specialize a component to, be from a more generic component to a specialized component. So you have dialog to sign up dialog. And in addition, there is a common convention that you'll see in React projects where you'll have presentational and container components. So what does this mean exactly? I call them smart and dumb components. But this is a separation of concerns thing. So presentational components are only concerned with how things look, so how they're going to render to the screen. While container components are only concerned with how things work. So container would be composed of one or more presentational components, and the container would be passing props to these components and handling the state. While the presentational component, you know, doesn't necessarily have state. It could have state, but generally it just gets all its values from props and then renders it to the screen. So it actually does the render to elements or even other components. So separation of concerns is good because it allows you to reuse those presentational components. It lets you uh, make those presentational components even simpler than they were, so you could really test them out without having them hooked into actual data. So that UI testers could really hammer them with all different kinds of values that could possibly be there. Uh, while the container components, those are just concerned with getting whatever values it needs to from whatever APIs and doing whatever calculations it needs to, and then setting up those presentational components. So then with those containers, you can really test uh, the logic and make sure that it is returning values you're expecting. So if you go through Abramov, who is very heavily involved in React, then you see why he says that presentational and container components should benefit of this approach and why you should use them. These aren't really necessary for a small project, but it's when you get into larger projects, you're definitely going to see patterns like this. And when you see a pattern like this, then the project tends to be easier to maintain and quicker to learn how it's working. So I recommend reading through this. He even calls smart and dumb components, but why is he not? It's overly harsh to the presentational components, and most importantly, to really explain the difference in the purpose. So this is the more PC version of smart and dumb components, presentational and container components. So inside of that blog post by Dan Abramov, you'll also see someone that's been using this guy Fantastic, using JSX for a year, and talking about how their company they separate presentation and container components in such a way that when you do code reviews, if you see something like this where this presentation component that is rendering comments to a screen is also making a call to get new comments. So in this case, it's using Ajax to access a JSON file, and it is then setting the state of the comments. So this is getting the data and rendering it to the screen as a list item. So instead, they recommend splitting it out so that you have a comment list that is only concerned with rendering comments. And then you have a comment list container. This would be your presentational, and this will be your container. In this case, it's only concerned with getting the data and passing it to the comment list. So using this, it is a familiar pattern with web developers called MVC that they can use that we're actually going to talk about a little bit later. But just know that it exists and that you'll see that explicit word container from time to time. And when you see that, that means that it's a component that contains a presentational component, one or more presentational components, and the container actually handles all of the data that the component would need. So it handles getting it from wherever it is to the presentational component. There's a lot. There's a lot of concepts in there. Uh, please let me know if you have questions. The uh, the project is due on Friday at 8 a.m. I'll be grading it then, or some delta after that. If you want a live grading session, let me know, and I can review your code. You can present it to me, and I can give you immediate feedback. Just hit me up with your Slack, and we can schedule that. Um, Otherwise, I will grade it, and I will put a grade, and you can check your feedback on Blackboard. All right, I hope you all have a good rest of the week, and I'll talk to you on Monday. All right, bye.